Hello again. So in this week's experiments, we are going to talk about the rates of reactions at two-factor rate law. So you notice that in this experiment, we are going to examine rate law and the order of a reaction that involves two reactants. In this, we will be monitoring the concentration of species by observing the color changes over the course of the reaction, and it should be able to help us understand other concepts like half-life of a chemical reaction. And therefore, you realize that we are investigating two different species and their concentrations will be nearly used up in the course of the reaction, and this is a little bit different from what we discussed when we looked at the chemical reaction involving the iodide, which was a catalyst for the decomposition of hydrogen peroxide. And we noticed that the iodide catalyst was not used up in the reaction, and therefore we were more concerned with the concentration of the hydrogen peroxide that was used up, but we only examined the rate of the reaction in the segment of the first few minutes when the reaction was happening. And therefore, for this new method where we are using two different species, it's going to make our calculations more complex, but there's a new way that will make sure that we still get to analyze and understand the rate law expressions by looking at the concept of pseudo rate constant. Here, instead of having the two concentrations vary or change over the course of the reaction, we increase the concentration of one of the species to be so high, like 1,000 times higher than the concentration of the other species. And so when it's really high, we assume that the concentration of these high species is not going to change over time. And this should make it a little bit simpler in analyzing the rate law. And so looking at the two reactants that we are going to deal with in this experiment, we have dye and we also have bleach. So dye is designed to absorb light and to produce an intense color because it has a lot of double bonds on adjacent atoms. And with dyes, when the double bonds get oxidized, they lose the intense color, and therefore the compounds becomes colorless. Bleach, on the other hand, is a common household cleaning agent, and it influences the solubility of dirt or stain, and therefore improves the appearance of the articles that's being cleaned. So bleach is an oxidizing agent, which makes it a perfect pair to react with the dye because we want the dye to be oxidized, and in that case the bleach is getting reduced. Bleach has an active ingredient called the hypochlorite ion that gives up its oxygen that oxidizes the dye and is reduced. The chloride is in a +1 oxidation state, and therefore this hypochlorite ion is reduced in the course of the reaction. And so as you look at the rate expression here, we have K as the constant, and then we have the concentration of the dye, and then we have M, which is the order with respect to the concentration of the dye, and then N is the order with respect to the bleach. But as we said, we are going to make the concentration of the hypochlorite to be so high that we assume it's kind of constant, and therefore we have this whole equation here, the constant and then the concentration of the bleach and the order with respect to the bleach represented by K prime. So pay attention to this equation here because it's important in your calculation. And therefore, what remains is that as we go through the course of our reaction, we can assume that the rate is only equal to the concentration that, you will go back here once you find out the other parameters, the concentration of the dye and the order of the reaction with respect to the dye. But instead of using concentration, we are actually going to replace the concentration variable with absorbance. So there is an equation that should relate the concentration of the dye with absorbance, and you need to pay attention to the absorbance value that I will point out at a later slide. Okay, so how do we go about understanding how to find the rate and the constant and the order of reaction with respect to the dye? Well, this is going to be a trial and error, but then the advantage is that we have integrated rate law expressions that are going to guide us to extract the information regarding the order of reaction, the overall rate law, the rate constant K, and the half-life of the reaction. And with the dye, the amount of light that is being absorbed over the course of reaction will be examined, and this should enable us to obtain values of absorbance and time. And once we have an absorbance versus time graph, we can generate other variables. So we have the absorbance versus time, we have the natural log of absorbance versus time, and we also have 1 divided by the concentrate, 1 divided by the absorbance value versus time. And as I said, because it's a trial and error, for you to find out the order with respect to the dye, once you obtain the absorbance values for one of the runs, you will want to plot these 3 graphs to obtain the most linear of these 3. If, for example, your most linear graph is the absorbance versus time, then the order of the reaction with respect to the dye is 0 order. And so that, let me go back here. So then the value that is next to the dye is going to be your if it's 0, then it's going to be 0. But if the graph of natural log of absorbance versus time is the most linear, then the order with respect to the dye is first order and your value is 1. And finally, if your graph with the 1 over absorbance versus time is linear, then your reaction is going to be second order, and that should also give you the value for that. And so you are going to use LogaPro to generate these other variables, because you will have this one provided for you, and I will also show you how to do that on LogaPro. And once you have obtained the slope of the graph, the slope of the most linear of the 3, well, you will decide on after plotting the 3 and you realize that one of them is the most linear, then whichever one that's most linear, your K prime will be the absolute number of the slope. So you could have a positive and negative slopes, but then just take the number itself. If it's -3, for example, and you just want to maintain the 3 and leave out the negative values, for you to use that as your K prime. So we have solved K prime, and remember that K prime was equal to K times the concentration of the bleach times the order of raised to the order of reaction of the with respect to the bleach. And now, since we have dealt with how to find the order of reaction with respect to the dye, let's delve into finding the order of reaction with respect to hypochlorite solution. With the hypochlorite solution, we are not going to do a lot of work as we did for the dye, and all that we have to do is just to compare the values obtained from the graph, the K prime values for each of the concentrations of the bleach. Now you are going to, after you find out the most linear graph, for example, if it's absorbance versus time, if you find that that's the most absorbent, and remember you had 3 runs, then plot the 3 different runs with the absorbance versus time values only. And once you plot the 3 runs, well, remember that the 3 runs had concentrations of bleach in like they were like half of each other. So you had 0.068, 0.034, and then 0.017. So you want to compare the K prime values for the different concentrations of bleach. Take for example the 0.34 and 0.017 concentrations. You are going to compare what the K prime values are for the two. If the K prime values are the same, then you know that you have a 0 order with respect to hypochlorite. If the K prime value doubles, say that is times 2, comparing the 2 runs, then that is a first order rate. That's a first order reaction. And if then the value of K prime is 4 times in one run compared to the other run, where the concentration of the bleach is doubling, then that is a second order reaction. And so with these two, we are able to find the order with respect to what? To the hypochlorite. Alright, so as I mentioned before, you have your bleach concentrations in 0.068, 0.034, and 0.017. So you realize that this is a double of this, and that 0.068 is a double of the 0.034. Anyway, so as I told you before, pay attention to this absorbance value right here, because you are going to use this value to convert the absorbance value of the dye to obtain the concentration. So you need this number in your calculations for the concentration of the dye. And then with the experiments, you guys have access to the video, so just watch what was happening to understand the necessary steps that led up to the results that you will be using. And again, as I said, because you're going to do the trial and error, you have to create new columns for your natural log of absorbance and also for the 1 divided by the absorbance values. And therefore, when you click on the data on your Logger Pro, you need to go all the way down to the new calculated column, and here you will put in your parameters. So what values will be on your x-axis and what values will be on your y-axis, and then well, for this new column, you actually just want to input the formulas. And here for the natural log of A, you have to select the ln, and then you highlight the column that already has your absorbance values, and then it will generate all the values for your natural log of A. And then for the column with 1 over A, you just want to also follow the same. You do the new calculated column, and then in the formula section, you put 1 divided by your absorbance value from the column that already exists, and just make sure that you have that value calculated for the rest of your data. Okay, so as you analyze the three graphs, we say that you have to consider the most linear of the three, and therefore take advantage of the linear fit feature in LoggerPro to help you find which one is the most linear, and then go by the parameters of that one to calculate for the other two runs. And in this question again, when determining the half-life of a reaction, which means how much time has gone by so that half of the material that you started with is consumed in the reaction. And this is just telling you to use LoggerPro because it's going to be a lot easier to find the point where your absorbance is decreased by half, and then from that time again find the other half-life and compare the two values. So this should be sufficient information for you to adequately answer all the questions that you have for your report sheet in this lab. Good luck to you.